All right, folks, let's talk about how to do number 1 on the warm-up, because this could show up on your CBA, and your CBA is when? Thursday. Okay, boys and girls, Thursday is also the last day of the 6 weeks, so I cannot let you make up the CBA if you don't do well on it, so you got to make sure you're paying attention. Okay, to find the equation of a line, you need a point and a slope. I told you the slope to use in a very tricky way, because I told you to be parallel to that line right there, and parallel lines have the same slope but different y-intercepts. Now, the problem is the slope is not 2. Usually the slope's in front of x if it's in the right form. This line is in what form? Standard form. I've got to modify it. Before I even can start the problem, I got to rearrange this stuff so I can tell what this slope is. That means the 2x has got to go to the other side with the 8. And then what? Divide everything by 4. And the only thing I care about is what is the slope? What is the slope? -1/2. So it took some work before I could really even start the problem. Okay, so that was my first step, figuring out what the slope is, right, Dylan? What am I missing now? Okay, well, what do I not know? The y-intercept. I have a point and I have a slope. So, Dylan, this is definitely a skill you got to have. I have to find the y-intercept. I plug in everything I know into y equals mx plus b. What's the y? 7. What's the m? -1/2. What's the x? And the b is what I'm trying to find. Now, if you don't like to do multiplying fractions with your brain, stick this in the calculator. -1/2 times -2, it should come out to be a positive 1. So now I have 7 equals 1 plus b, and I'm almost done. What's that b value? 6. So now I know the slope. I just figured out the y-intercept. Now I can write my equation. Y equals -1/2 x plus 6. What's one thing I could check? I could make sure that this line does indeed have this point. That's at least one thing I could check. And I would definitely suggest you check your answers whenever you can on the CBA, on the mock star, on the real star. There's y equals -1/2 x plus 6. I'm looking for the point, I'm looking for the point -2, and there it is. Now, the one thing I'm not 100% sure about is if I had the right slope. But I can at least verify that this is on this line. And if you're not sure if you got the right slope, then just double check yourself. Do it again. But we did. We got the right slope. Now, what else might they do after doing all that work? And they might have the answers in standard form. So you do all that work, and that's several steps there. You got to have a lot of stamina for questions like this. You get your lovely answer, you know it's right, and it's not down there in the answer choices because they put everything in standard form. It's not that hard to convert this. What would I do to make this in standard form? Multiply everything by 2 so that these 2's will cancel out. And what would I have? 2y equals -x plus 12. And then move that x over there, and you've got x plus 2y equals 12. That's just another way they might have the answer. But look how different they look. So don't get discouraged if you don't see your answer down there. Perhaps they just changed the form. All right, and then last night you did intercepts, and we're going to do that again today as well, and it's going to be easy. Okay, nobody, I hope, would miss the y-intercept. What's the y-intercept here? 12. When it's in slope-intercept form, of course, y-intercept is showing. X-intercept, and this is what you missed if you were absent, so you better be paying attention. Y-intercept is 12. X-intercept, for any function. If you want to find the x-intercept, that happens when the y value is a 0. So for any function, if you want to work it out mathematically, if you're trying to find the x-intercepts, take the y's out and put zeros in their place. Now, I need to make this more user-friendly. I want to get rid of that fraction, so I'm going to multiply everything by 3. 3 times 0 is still 0. 3 times -1/3 just becomes a giant -1x. And 3 times 12 is 36, and now I'm almost done. I would just move this -x to the other side, and I'm done. What's the x-intercept here? 36. Now, what if I wanted you to write those as points? If the y-intercept is 12, what point is that? 0, 12. If the x-intercept is 36, what point is that? So one thing I could do to check it, whoops, is put that equation into y equals and look at my t-chart for those points. But you do have to know what intercepts look like as points. Negative 1/3 x plus 12. Oopsie. And then we're looking for 0, 12 is there. And then I also want to check that 36, 0 is there. So I'm going to tell my table to start at 36 so I don't have to scroll. And there it is. Now, some kids, maybe you like to do this in your calculator. What's another word for an x-intercept? A 0. An x-intercept is the same thing as 0. So here's yet another way. If it's in slope-intercept form, put the equation in, and then also put in y equals 0, and then you calculate where they do what? Intersect. Now the problem is this isn't crossing the x-axis until 36. That's way off of my picture. So what would I have to do? I can't even see any of the line. I'd have to zoom. Well, it's still trying to graph the line. The y-intercept is way up here at 12. The x-intercept is at 36. You see how I see just a little portion of it right there? I'd have to zoom out or edit the window. But you got to be able to see where it's crossing, and then you would just tell the calculator to calculate intersection, first curve, second curve, guess. And there it is, 36, 0. Okay, those are skills you got to have, guys. Lots of different ways to do linear problems, lots of different forms for the answers. You got to know them all. Okay, we're going to grade the homework after. Let's go ahead and get through one of the things that I feel like is going to be on the CBA, and it's called direct variation. So that's your title for your notes, direct variation. Sometimes it's called proportional. And I think you might have done this last year. I'm not 100% sure. It's just a special kind of line. Normally, how are we used to seeing lines? Y equals mx plus b. Well, this is a very special line, and it's written like this. Y equals kx. What's missing? The b. Guess what the b always is? 0. If you are a direct variation situation, that means you have to be a line, and you have to go through 0, 0. Always. So it's always linear, and it's always containing the point 0, 0. So the y-intercept is always 0, always. That makes it easy. That's why they don't even write the plus b, because it's going to be a plus 0. I mean, we could write that if we want to, but they just usually don't write anything. Now, what's the other thing that looks weird about this compared to y equals mx plus b? They call slope k instead of m. Okay, it's really the same thing. K just means slope. Sometimes they call it the constant of variation, which again just means slope. And the reason why I think they give it its own special letter is because it's super easy to find slope when it's direct variation. And this is why it's super easy. What's one point that you always know? 0, 0. Because let's think about how we normally find slope. We normally do 2 y values subtracted on top and 2 different x values subtracted on bottom, right? Normally you need how many points to find slope? 2. You need an x and a y on 2 different points. But for this type of problem, you don't need 2 points. You only need 1 point. And the reason why you only need 1 point is because you automatically already have a second point. What's the second point always going to be? 0, 0. So you need 1 point besides 0, 0. So instead of having to do y2 minus y1, you could just do y minus 0 over x minus 0. You always use 0, 0 as one of your points. And basically that means you don't even have to worry about that part. So guess what the slope is always? It's just y over x. So this is the one time where slope doesn't have to involve subtraction. It's just whatever your y value is over whatever your x value is. Because really we are subtracting, but we're always subtracting the 0, 0 point. So it doesn't really affect anything. And that's why they give it its own special name. Because normally Normally you can't do that on slope. Only on direct variation problems can you do that. So they call it its own special thing, k, instead of m. But it's the same exact thing. Here's the hardest thing about direct variation. You've got to figure out what's independent and what's dependent just by reading the situation. Because you got to know what your x number is and what your y number is, and then you can find slope, and then you can write the equation. Super, super easy. So let's look at a problem. These are directly off old end of course exams here. So look at this situation about Frank's salary. How do I know it's direct variation? But how do I know this is going to be a direct variation situation? Because it says it right here. So as soon as you see that, you need to think, oh, that's one of those special lines. It has to go through 0, 0. And I only need 1 point, and I can write the whole equation. Normally we need 2 points, but not on direct variation. Because remember, the other point we automatically know is 0, 0. Now here's my dilemma. I've got a money amount and a time amount. I have got to figure out what's independent and what's dependent. Yet almost always when time is involved, guys, usually if time is involved, that's usually your independent variable. But think about it. Does his time depend on how much money he earned? Or does his money he earned depend on how much time he's working? Yeah, how much money you make depends on how many hours you work. So what's the independent number here? The time. What number is independent then? Okay, don't even look at these questions. Look at the situation at the top. 15. What's dependent in this problem? $187.50. What's the other point I automatically know? 0, 0. Because if he works 0 hours, he's going to get $0. So that's why I only need 1 point to find slope. And they even give slope its own special name. They call it k, but we can also call it slope if we wanted to. Instead of having to do y minus y over x minus x, it's just y over x. So do that. Tell me what the slope is. Use your calculator. 187.50 divided by 15. That's what my slope is going to be. In other words, that's the dollars per hour. You're finding his hourly rate. For this type of line, that's why they don't call it m, because m is always y minus y over x minus x. For this type of line, they call it k, which is just y over x. We get to skip the subtracting part, even though really we are subtracting zeros, because one of the points has to be 0, 0. So do you see this is slope's always a rate. The dollars per hour is what we're finding here. How many dollars per hour does he make? $12.50. He makes $12.50 an hour. So can you write the whole equation then? What's the whole equation? Y equals 1250 x. I hear a lot of talking back there. It's not Mia. All right, y equals 1250x. That's the equation. Why did I not have to find the y-intercept? There is a y-intercept. What is it? 0. Because if he makes, if he works for 0 hours, he's going to make $0. Another way we might put this is P equals 1250h. His pay, it depends on how many hours. They might use variables that are more relational to the situation here. Okay, so are you okay with how I found the equation? Basically, the only thing I had to figure out was slope, and then I could write the whole equation. Now, once you have your equation, you got to know how to use it, depending on the situation that they give you. Constant of variation, we figured that out. It's $12.50 per hour. Slope's always a rate. An equation to represent the situation, we already wrote it. Now, look at these two different types of problems, folks. Are y'all looking up here? How much will he earn for 40 hours of work? Where do I put this? That's an X number. That's not a Y number. That's an X number, right? So I'm going to put it in place of X. So use your calculator and figure it out for me. Yeah, just use your calculator. What does it come out to be? He would earn $500 if he worked for 40 hours. Okay, so I got to know how to use the equation once I write it. If they give me an x value, I stick that number in for x. Now look at the next situation. How many hours must he work to earn $312.50? That's a little bit different. That's not a time number. That's a money number. So where do I put that? I put that in for the y. So the way I solve this is a little bit different. How do I do this? I got to divide. Use your calculator and divide. Is it 25 hours? Okay, so you can use the equation to figure out y values or to figure out x values. It just depends on the situation. And again, I think the hardest thing is figuring out what is independent and what is dependent. Okay, look at this problem, please. Read it, let it sink in. I know you guys probably have never taken out a loan, but unfortunately they ask about loan questions all the time on the 8th grade and 9th grade stars. Do y'all know what interest means? What is interest? Right, when you need to borrow money from the bank, do they just say, sure, here's the money, pay it back whenever you can? No, they charge you money to use their money, and the money that they charge you is called interest. You have to pay back everything you borrow, and you have to pay back what's called interest. Now, we've got a loan amount and an interest amount. Do you see what I'm talking about? What's my loan amount in this problem? 500. What's my interest amount? Now, what do you think depends on what? What's independent and what's dependent? Yes, how much you borrow is independent. You might want to borrow a little bit to buy a car. You might want to borrow a lot to buy a house. Okay, so independent in this case would be the loan. How much you choose to get for the loan. What's dependent? The interest, because the more you borrow, guess what? The more interest you pay. So what you're putting into this is loan amount, and what you're getting back is interest amount. So what order would we write this point in then? 500, 75. Now, I only have 1 point, but I know that this is direct variation because it pretty much told me that. Proportional means direct variation. That means I only need 1 point, and I can write the whole equation. What's the y-intercept automatically on this problem? 0, because if I don't borrow any money, I don't owe any interest, so the y-intercept is 0. Now, what is the slope, though? Use your calculator and figure it out. You can't just look up here. Use your calculator and figure it out. How do you find slope? Okay, I need to see y'all picking up your calculator and doing a problem now. Slope. Find it. How do you find slope? Okay, no, slope is not y minus x. In this case, slope is y over x. Normally you would do y minus y over x minus x, except one of the points we know is 0, 0, so we can skip the subtraction part. I need to see you doing some division. What is it? 0.15. You got to do 500 divided by 75. I'm sorry. 75 divided by 500. It's y divided by x. That's what slope is, and in this case they call it k. So what does it come out to be? 0.15. My slope, or my k value, my constant of variation, is 0.15. What does that mean, do you think? And this is the one case, if you're talking about money, I don't mind if you leave it as decimals. Guys, I need y'all invested in this. I can tell you really don't care about this right now, but you're going to care about it on Thursday. And when you tell me I don't get that kind of problem, I'm going to say sorry. This means you're paying 15 cents extra for every dollar you borrow. You're paying 15 cents on the dollar for interest. What's the equation going to be? Y equals 0.15 x. Somebody said 3 over 20. That's correct as well. That means for every $20 you borrow, you got to pay back an extra 3. On direct variation, please make sure the x is either separate from the fraction if you write it as a fraction, or it goes on top. The x should never be on the bottom of a fraction for direct variation, so keep that in mind. Okay, next question. Read this. I want you to see if you can figure out what is independent and what is dependent. Get one off my desk if you're missing a calculator. One of the yellow ones died because you guys dropped them so much. Yeah, and if you kill that calculator, that's the one you killed right there. Well, just try it. It does weird things because you've dropped it on its head way too many times. Exactly. Get the other one. All right, what's independent here? Yeah, the height it bounces depends on how high you choose to drop it from. If you drop it from a really high height, it's going to bounce high. If you drop it from a very low height, it's not going to bounce as high. So what's independent is the drop height. What's dependent is the bounce height. How high it bounces depends on how high you dropped it from. So look at the two pieces of information we were given. It bounces 30 centimeters when dropped from a height of 50. So what order does that point go in? 50, 30. Because you're inputting drop heights, you're getting back bounce heights. It's not going to bounce as high as it was dropped. What is the constant of variation here? In other words, the slope. Now the y-intercept is 0. The slope is not 0. 30 over 50, use your calculator, it's 0.6. So what's the equation? Y equals 0.6 x. Now, what are you putting in? You're putting in drop heights. What are you getting out? Bounce heights. So look at this question. How high will the ball bounce if it's dropped from a height of 120? Where would you put that 120? Is that a y or an x? That's an x. So what would I do with that number? Times it by 0.6. So what would the answer to the question be? 72. If I wanted to answer that question, 72 centimeters. So you got to be able to write the equation, then you got to be able to use the equation if they ask you to. The trickiest part is figuring out which one's the y and the x, because that's going to determine what your slope is. Y-intercept is always 0. All right, this one was directly off the end of course exam 2 years ago. They wanted you to write an equation that matches this situation. So from one point, we can write the equation of a line. And the only reason we can do that is because it's that special case of direct variation. Independent is is x. Dependent is y. Independent is what you put in. Dependent is what comes out. Independent is always x, dependent is always y. Okay, so we were given just one piece of information, 1 point. There are 160 calories in an 8-ounce glass of milk. So how do you think that goes in as a point? Yeah, the calories depend on how many ounces. So you would input an 8-ounce glass of milk and you would figure out that is 160 calories. You're inputting ounces and you're getting back calories. So when I find the slope, I'm finding the what per what. The calories per ounce. What are the calories per ounce here? It's 20 calories per ounce. How did you find that? Y over X. So the K, or the constant of variation, otherwise known as slope, is 20 calories per ounce. So what would the equation be then? Y equals 20x. Absolutely. Okay, try this one. Now, I know that now we have Google Maps. We don't usually use this kind of thing much anymore. But back in the old days, you'd have to get out a map and measure the distance from the cities and use the little key on the map to see how long it was on the map. And then you could figure out how far apart those cities were in real life. Have y'all ever done those kinds of questions in social studies? Now, here's the one piece of information we were given. You have to figure out what's independent and what's dependent. Does map distance depend on real life, or does real life distance depend on map distance? Yeah, you're trying to figure out the real distance. What do you need to figure out the real distance? The map distance. So which one of these would go in for x and y? Yeah, you're inputting distances from the map, and you're getting back distances in real life. So the input is the map, the output is the real life. Because we're using the map to figure out the real life distances. So what's the constant of variation here, otherwise known as slope? 12.5. So what's the equation? Y equals 12.5x. So you're going to input how many centimeters apart they are on the map, and what you're going to get back is that's how far apart they are in real life. Now, one other thing. What if they have it as a fraction? Take 12.5 and make it a fraction. Or just turn it back before you actually did the division. 25 over 2. Now please be careful, because they might show you the answer this way. They might show you the answer this way. Both of these were answer choices, and lots of kids fell for the wrong one. Where does the x go? If it's not out to the side, which is how I prefer it, then it better be in the top. The x should not be on the bottom ever in direct variation. So watch out for that. Okay, now let's look at some pictures. You might be asked to identify direct variation from a picture. Is this direct variation? No, why not? It's not going through the origin. Is this direct variation? Yes. Is this? No, why not? It's not linear. Direct variation is linear. Is this direct variation? No, why not? The y-intercept. Is this? No, because it's not linear. What about this? Yes. What about this? Well, I really can't tell because it's in standard form, but is it going to have a y-intercept? Yeah, so this would be no. What about this one, though? That one is, because look what happens when I put it in slope-intercept form. 4y equals negative 2x, y equals negative 1/2 x. The y-intercept is 0, so this is yes. So it has to be linear, has to have a y-intercept of 0. In other words, it has to go through the origin. Alright, so that's all I have for you for direct variation. Now, this next part is going to be super easy because it's basically just building on yesterday's lesson. We're going to go back to homework tonight is still finding intercepts. Yes, except this time the line I'm going to give you is in standard form. But guess what? That's one of the very nice uses for standard form of a line. If a line's in standard form, then finding the zeros really becomes very, very simple. Maybe not for the y-intercept, because with y-intercept all we need is to look at the equation for slope-intercept. But it's still not hard. Okay, look at this problem. 6x plus 2y equals 10. Do you agree that's in standard form? Unfortunately, we can't identify the y-intercept right away. The y-intercept is not 10 because it's not in slope-intercept form. It is 5. Wow, how'd you do that so fast? It is simple. Did we do these yesterday? To find the y-intercept, what do? Put in 0 for what? X. The y-intercept happens when x is 0. Sometimes this is called the cover-up method. So if I want to find the y-intercept, I'm going to put a 0 in for x, and guess what's going to happen to this? It basically just disappears. So we're going to cover up the x's, and we have a simple little one-step equation. 2y equals 10. What does y equal? 5. The y-intercept is 5. You're the one that just told me it was 5. I didn't cancel the x out. Y-intercepts on any kind of function happen when the x value is 0. So what I did is I put a 0 in for x, and 6 times 0 became a giant 0, which kind of makes it irrelevant, so I just covered it up. Okay, now let's go back to the original equation. 6x plus 2y equals 10. I found the y-intercept is 5. Now I got to find the x-intercept. Well, when do x-intercepts happen? When the y is 0. So if I want to find an x-intercept, I put in 0 for y. I'm going to put a 0 here for y. What's 2 times 0? So basically the y's disappear. If I'm finding the x-intercept, the y's are going to disappear. 6x equals 10. What does x equal? 10 over 6. I don't mind improper fractions, but that one can be reduced. 5 over 3. So the x-intercept is 5/3. So again, sometimes this is called the cover-up method. If you want the y-intercept, cover up the x's, because you're really putting a 0 in for x. If you want the x-intercept, cover up the y's. What you're really doing is putting a 0 in for y. And then you've got just a little baby equation. All right, let's go back and really understand what these points would mean. If the y-intercept is 5, what point is that? 0, 5, because we put a 0 in for x. If the x-intercept is 5/3, that's 5/3, comma 0, because we put a 0 in for y. You don't have to put points on your homework. You just have to list and label, Make sure you label it for me. All right, 2x plus 6y equals -3. What's the y-intercept? -1/2. Okay, if I want to find the y-intercept, I'm going to put a 0 in for x, which basically makes this whole thing just become a giant 0. I just can cover it up. 6y equals 3, so y would equal -3 over 6, which is -1/2. Go back to 2x plus 6y equals -3. If I want the x-intercept, that means I can cancel out the y's, because I'm going to put a 0 in for y, and 6 times 0 is 0, so the y's just get covered up and disappear pretty much. So the x-intercept is -3/2. This is what I want to see on your homework. Labels, and then just tell me the intercept. You can use your finger. If you want the y-intercept, cover up the x's, answer the equation. You want the x-intercept, cover up the y's, and answer the little baby equation. All right, you try this one, number 3. 4x minus 2y equals 1. I want you to find y-intercept. X-intercept, please make sure you label it, especially on your homework. These go so fast, it's almost like you can just literally cover it up with your finger and solve the little one-step equation. Okay, so if I want the y-intercept, I'm going to cover up the x's, pretend like you can't see them. What's the y-intercept? -1/2. 1 divided by -2. If I want the x-intercept, I'm going to cover up the y's, pretend like you can't see them. What's the x-intercept? 1/4. Write the equation and then just, yeah, pretty much. See how nice standard form is for finding intercepts. That's one of the uses. Now, two little tricky situations. Number 4, y equals 3. Find the y-intercept, find the x-intercept. The y-intercept is 3, absolutely. What about the x-intercept? Do not put 0. That means just crossing the x-axis at 0. I would just prefer you to write none. There isn't one. It's not really undefined, it doesn't exist. Think about what y equals 3 looks like. Does it ever cross the x-axis? Horizontal lines will never cross the x-axis. Okay, now what about this? Number 5. X equals -2. What's the y-intercept? There isn't one. This is a vertical line that goes straight up and down through -2. It's never going to cross the y-axis. What's the x-intercept, though? -2. Okay, so horizontal lines have y-intercepts and no x-intercept. Vertical lines have x-intercepts, but no y-intercept. And you might have one of those on your homework. Okay, your homework is page 316. Please listen to my directions because it's not what it says in the book. All you got to do is 1 through 10. I want you to find y-intercept, find x-intercept, just like we just did on our notes. And that's all you've got to do. Okay, and then let's real quickly grade yesterday's homework. Write this down so I can switch screens.